Dear students, in the previous lecture I have discussed about project selection model. There I have explained numeric and non-numeric models. In this lecture I am going to show you some examples of numerical models. By using the numeric models, how to select various projects. Just to recollect where we are now. See, initially I talked about the project selection model on 2 lectures, then I had discussed about agile project management. The previous lecture I discussed about project selection model. Currently I am going to give some example of project selection model. The agenda for this lecture is net present value, weighted scoring model, internal rate of return and AHP. These are the techniques used for project selection model. After explaining each techniques, I am going to use Excel to give you a demo on how to use Excel for selecting a project. First I am going to explain the net present value. As I explained previously, the net present value of a project is the sum of present value of all the cash flows. Generally we use positive as well as negative. The cash inflows is taken as positive and cash outflows is taken as negative, that are expected to occur over the life of the project. The general formula for NPV is NPV equal to sigma T equal to 1 to n Ct upon 1 plus R to the power T. Here Ct is the cash flows at the end of the year T and the n is the life of the project and R is the discount rate. Now I am going to explain how to use NPV with the help of an example. The example 1 is Siddharth bought a house of $750,000 and sold it a year later for $990,000 after deducting any realtor's fees and taxes. Now calculate the NPV if the rate of return is 5%. So what are the data is given to us? Investment on buying the house $750,000, monetary received from sale a year later is $990,000, that is CT. The rate of return R is 5%. Now we will use NPV formula. NPV is CT upon 1 plus R to the power T. What is CT? Cash value at the time period 1 plus rate of return to the power of time period. So the cash value at time period, that is after selling, how much is getting? $990,000 upon 1 plus R to the power 1. So when you simplify that, we are getting first present value. So present value is $942,857, that is a present value. Now we have to find out the net present value. So when you subtract from this present value minus our initial investment, that is $750,000, you are getting $192,857. Therefore, for 5% rate of return, the investment has NPV of $192,857. More example which is related to the project. I have a project, the cost of capital R for that firm is 10%. The net present value of the proposal is like this. So 0th year you are investing $1 million. See, I have put that 1 million in the bracket, that implies negative because that is a cash outflow which goes away from the pocket. So I, instead of using negative, I put bracket sign. So first year cash inflow is $200,000, second year 200,000, third year 300, fourth year $300,000 and fifth year $350,000. Now we are going to find out the net present value of this proposal. The NPV is, because that 1 million is our initial investment. So, 1 minus 1 million, that minus sign is more important, plus the cash inflows for next 5 years. So, $200,000 upon, here R is 10%, the cost of capital is 10%. So, the net present value is minus 5,272 rupees. Here we are getting NPV is negative, in the sense it is not a good proposal for us. So, the net present value represents the net benefit over and above the compensation for time and risk. So, we are getting negative value. So, this is not advisable proposal. Now, I will explain how to use Excel. So, in this problem it is given in the 0th year, the investment is 1 million rupees. So, we are getting cash inflow for next 5 years 200,000, 200,000, 300,000, 300,000, again 350,000. So, the discount rate is 10%. So, already I have calculated, but I am going to redo it for your understanding. So, you type equal to sign. So, NPV. So, it is asking internal rate of return. So, it is a 10%, then you have to freeze this. So, F4 comma all the values. So, this is my present value. If I want to do the net present value, this value equal to this value minus the investment. So, it implies that the net present value is negative. So, if it is a net present value is negative, we will not go for that proposal. So, the decision rule associated with net present value criterion is like this: accept the project if the net present value is positive. In our example, our net present value has come negative. So, we should not choose that proposal. The second, reject the project if the net present value is negative. If the NPV is 0, it is a matter of indifferent. Next, we will go to another project selection model, weighted scoring model. Is a very popular model. Consider buying a house as a project. You have different criteria by which you are going to make the decision. So, for buying a house, the location is one criteria, that is the neighborhood and proximity to amenities, work and schools. The price is another criteria, the cost of the home and associated expenses. Size, the square footage and the number of rooms in the house is another criteria. Safety, the security of the area and the crime rate is one criteria. Then resale value, the potential for the home's value to appreciate over time. Then the school quality, the quality of schools in the area for the families with children. So, these are the some criteria for choosing a house. Here choosing a house is a project. We can have some other criteria, this I have given only for the illustration purpose. So, we got the weightage from the expert for all 6 criteria. For example, location, the criteria is 10%, price 7%, size is 17% and safety is 12%, resale value 24%. You see the highest weightage is given by the expert is school quality, that is a 30%. So, we have the criteria and the weightage, and there are some alternatives. By using this criteria and their alternative, I am going to find the weighted sum. So, here there are 5 alternatives there. So, first step is multiplying the score for the new house with respect to criteria 1, that is a location. So, the score is 3, then multiplied by corresponding weightage. So, 3 multiplied by 0.10, it is 0.3. Then with respect to price, the criteria for the new house is 1. So, here, so this number is a score, for example 3, 1, 4, 2, 1, 3. The other one, this 0.10, 0.07, this is the weightage. So, I am multiplying the score with their corresponding weightage, then I am summing it. So, when I sum it, it is 3.06 for first alternative house 1. For second alternative, there is a score and multiplying by weight. So, I am getting 3.73. For third one, we are getting 3.05. For fourth one, it is 2.61. The fifth one is 3.58. So, now we have to make the decision by looking at the highest weighted sum. So, 3.73 is the highest weighted sum. So, we are finalizing that the alternative 2, that is a new house alternative 2. So, this is the way to use weighted scoring model for choosing a project. The third example which I am going to discuss now is internal rate of return. See, there is a close connection between NPV and internal rate of return. You remember, in the NPV formula, it will be like this. So, what will happen? This in x axis is the interest rate, y axis is NPV. So, what will happen? It will go like this. When you increase the interest rate, the value of NPV will decrease, right. So, when you decrease the interest rate, value of NPV will NPV will increase. So, we want to know a particular interest rate where your NPV is 0. So, the interest rate at which the NPV 0 is nothing but your internal rate of return. So, the internal rate of return of a project is the discount rate, which makes an NPV equal to 0. Put differently, it is a discount rate which equates the present value of future cash flows with the initial investment. It is the value of R in the following equation. Investment is equal to your present value. So, what interest rate will bring your present value to the investment? So, that interest rate is nothing but internal rate of return. In this equation, CT is the cash flow at the end of the year, T, R is the internal rate of return. Here the objective is we have to find out what is the value of R, otherwise what is the interest rate that will make the present value is equal to 0, net present value is equal to 0. In the NPV calculation, we assume that the discount rate is known and we have determined the NPV. In the IRR calculation, we set the NPV equal to 0 and determine the discount rate that satisfy this condition. This is the connection between NPV and IRR. To illustrate the calculation of IRR, consider the cash flows of a project being considered by some company. So, the initial investment is say $100,000, and every year for next 4 years we are getting cash inflow 30,000, 30,000, 40,000, 45,000. Now, we have to find out the internal rate of return. The internal rate of return is the value of R which satisfy the following equation for the given problem. So, we know our initial investment is 100,000 and there is a cash inflow for next 4 years. So, in this equation we have to find out the value of R. The calculation of R involves a process of trial and error because it is a non-linear relationship. We try different values of R till we find the right hand side of the above equation is equal to 100,000. Randomly, let us try to begin with R equal to 15%. So, when I make R equal to 15%, when I find the present value, it is getting 100,801. It is just above the your 100,000. So, if you want to decrease this, as I told you, there is a interest rate and the NPV is having the inverse relationship. So, it will be like this. So, where it is touching here. So, now we have to find out the R when NPV become 0. So, now if I increase the R value, the NP will decrease. So, what I am going to do from 15% I am going to for 16%. So, we increase the value of R from 15 to 16%. As I told you, in general the higher R lowers and the smaller R increases the right hand side value. So, when I use 16%, so I am getting 98,636. Now, we got an idea that interest rate is going to be between your 15 and 16%. Since the value is now less than 100,000, we conclude that the value of R lies between 15% and 16%. Many times this approximate value is enough. For most of the purposes, this indication is enough, but if you want to know the accurate value, there is one methodology that has to be followed. If a more refined estimate of R is needed, use the following procedure. Determine the net present value of the two closest rates of return. For example, find the NPV when interest rate is 15%, we are getting 801. Then find the NPV when the interest rate is 16%, we are getting minus 1363. Find the sum of absolute values of the net present value obtained in step 1, that is sum of 801 plus 1363, we are getting 2164. Calculate the ratio of net present value of the smaller discount rate identified in step 1 to the sum obtained in the step 2. See, the smaller discount rate, the smaller NPV is 801 upon the sum is 2164. When you simplify, we are getting 0.37. So, add the number obtained in step 3 to the smallest discount rate, that is a 15% the smallest discount rate plus 0.37. So, the refined value is 15.37. So, the decision rule for IRR is as follows: accept if the IRR is greater than the cost of capital. What is the meaning of cost of capital here? Suppose you are borrowing some money from banks, say 10%, your IRR is 12%, then we can accept the project. If the IRR is less than 10%, for example 9%, we cannot accept the project. So, reject if the IRR is less than the cost of capital. So, these are the decision criteria for internal rate of return. Now, I am going to explain with the help of Excel how to find out internal rate of return. Now, already I have calculated 15.37%, I am going to redo it for your understanding. So, equal to IRR, internal rate of return. So, select all the values from the 0 onwards. So, we are getting 15%, you have to make it more decimal. So, here make it to decimal places 4. Yeah, you are getting 15.37%. So, this is the way to use Excel to find out the internal rate of return. Another popular method, a multi-criteria decision making techniques for choosing a project is analytic hierarchy process. Analytic hierarchy process is a multi-criteria decision making techniques introduced by Professor T.L. Sati. Different studies have been carried out in the past to determine the optimal size, location, technology for by using other multi-criteria decision making methods, but this AHP, this is most popular and easy to follow. Now, I have assumed that you have a project. So, that project is selecting a car is a project. You are going to use an AHP method to select a car by considering certain criteria. The advantage of AHP is we are trying to make a well informed decision by analyzing different criteria in order to compare 3 cars. So, there are 3 alternatives A, B, C and determine which is the best car for the selection. This methodology also for the purpose of illustration, you can take a real time project and we can have a criteria which is relevant to the project that can be used for choosing the project by using AHP. But here only for the explaining the methodology of AHP, I have taken a very simple example selecting a car as a project. I am going to explain this AHP methodology by using Excel. So, for selecting the car, assume that there are 4 criteria. One is the price, another one is miles per gallon, the third one is comfort and style. The same value I have written in row wise and column wise. Now, I am going to get some value, pairwise comparison value from the person who is willing to buy a car. So, I have entered 3. So, what is the meaning of this 3 is, if the person compares price versus miles per gallon, so the price is 3 times more important than the miles per gallon. For example, there is a 4. What does that 4 implies? That comfort is 4 times more important than the miles per gallon. For example, here 2, style and comfort. So, style is 2 times more important than the comfort. So, these values 322, 442 which I got from the experts, the person who is going to make the decision. You see the diagonal value obviously it will be 1 1. Okay. So, after entering this, now you see for example, when you compare price and miles per gallon it is 3. If you compare miles per gallon versus price, it should be inverse of that 3. So, it will be 1 by 3. So, if you compare price versus comfort, it is 2. If you compare comfort versus price, it should be 1 by 2. Just the inverse of the upper triangle has to be written here in the bottom triangle. Now, after writing the inverse, then you will be filling the whole tables, the pairwise comparison. First, you have to do the column sum. For example, the price column 1, 1 by 3, 1 by 2, 1 by 2. So, first I have done the column sum. Similarly, for miles per gallon, column sum. Similarly, for comfort, column sum. Similarly, for style, column sum. The next step is each element for example, 1 has to be divided by the column sum. So, if you divide 1 upon 2.33, we are getting 4.285, for example 4.3 if you consider only 2 decimal. So, everywhere we will consider only 2 decimal here. Okay. Similarly, for the second column 3 upon 12, 3 upon 12 is 1 by 4, it is 0.25. So, 1 upon 12 0.08, 1 upon 4 upon 12 1 by 3. So, it is a 0.33. So, each element has to be divided by its column sum, that is a step 2. In step 3, we are going to find out the row average. You see that this row is there. No, for example, price is one row. So, I have found the average of this row where the price is written. Similarly, the average of this miles per gallon. So, this average value represents the priority 0.4, 0.09, 0.22, 0.30. So, what it implies? If I compare these 4 criteria, the highest weightage for criteria is given to the price, 40% weightage is given to the price. The next highest weightage is to style. The next highest weightage is comfort. The least weightage is only 9%, which was given by the experts. So, this is a way to get the weightage for each criteria. Before proceeding further, we have to check a concept called consistency ratio. What is the meaning of consistency ratio? When the respondent is given some pairwise comparison value, we have to compare, we have to identify whether the respondent is given a consistent value or not. For example, A is one criteria and B is one criteria. Suppose when I compare A and B, for example, I am getting 3. When I compare A and 3, so A is 3 times more important than B. Similarly, if I compare B and C, for example, when I compare B and C, I written 2. So, B is 2 times more important than C. Suppose if I want to compare A and C, it should be greater than 6, because when I compare pairwise comparison A and B, A is 3 times more important. When I compare B and C, B is 3 times more important than C. If I compare A and C, it should be 6 and above, it should be minimum 6 and above. In case the respondent is given weightage say 5, so that means that the respondent is inconsistent in giving the value for the pairwise comparison. This is the meaning of this consistency that I am going to find out for each matrix, each pairwise comparison matrix. Here the pairwise comparison matrix is a criteria. We have considered 4 criteria. So, how to find out that pairwise comparison matrix? I go back to my presentation now. Yeah, how to check the consistency? So, consistency of data is checked according to the procedure suggested by TLSRT. The consistency check is done by performing consistency ratio check. How to find out consistency ratio? Consistency index upon random index. So, the consistency ratio is equal to consistency index upon random index. Random index is mean consistency indices for randomly generated pairwise comparison matrix. What is the random index? Random index is mean consistency indices which was obtained for a randomly generated pairwise comparison matrix. That value can be directly obtained from the table. But now, how to find out consistency index? For that, you see the formula lambda max minus n upon n minus 1. N is the size of the matrix, for here it is a 4, we have to find out the lambda max. So, that lambda max I am going to calculate it. Please look at this portion of the Excel. A is the initial pairwise comparison matrix which was given by the respondent. X is the criteria weightage which we have obtained from for each criteria. Then we have to multiply AX. AX is a matrix multiplication. So, when you do the matrix multiplication. Excel there is a function mult, you have to select cell matrix 1 matrix 2, then we will get this value. Then, so for example 0.4 upon 1.71, that is a P. So, next we have to find out 1.71, that is a P42 upon N42. Similarly, how we got 3.92? 0.3533 upon 0.09. Then 0.93 upon 0.22, we are getting 4.22. Then 1.3 upon 0.33, we are getting 4.33. So, the average value of these 4 values is nothing but your lambda max. So, the lambda max is 4.190. Now, I will go back to my presentation. We know that consistency ratio is consistency index upon random index. How to find out the consistency index? By using lambda max minus n upon n minus 1. With the help of Excel, I have explained how to find out the lambda max. N is the size of the matrix. By using these values, first we will find out consistency index. So, consistency index is lambda max, which I got from our Excel, minus 4, because our size of the matrix is 4 cross 4 is a 4 upon 3. So, consistency index is 0.063. Next we have to find out the random index. This value which you can directly get from the table, but already I have explained the meaning of random index, that is the average value of consistency for randomly generated pairwise comparison matrix. Here for 4 cross 4 matrix, the value of random index is 0.90. So, when you divide consistency index upon your 0.90, you are getting 0.07. This 0.07 is less than 10%, that is less than 0.10. We can conclude that pairwise comparison matrix is consistent. Once we conclude that it is a consistent, we can go for further calculation. If it is not consistent, for example, consistency ratio is more than 10%, then we have to ask the respondent to provide new pairwise comparison matrix values, then we have to redo all our procedures, what I have done it so far. So, we got consistency ratio is 0.07, so we have accepted. Now, we have to do the pairwise comparison of these 3 alternative with respect to each criteria. For example, the price is one criteria, there are 3 types of car is available A, B, C, then we are doing pairwise comparison. After pairwise comparison, we are finding the column sum, then I am dividing each element by column sum, then that is this element, then I am finding the row average. So, for alternative A with respect to price, the weightage is 14%, for B it is 29%, for C it is 56%. So, what is the meaning of that? Suppose the price is only criteria, the best alternative car is car C, because it is a 56%. Similarly, for comfort, I am repeating the same procedure. What is that one? I have the pairwise comparison matrix, I am finding the column sum, then each element is divided by the column sum, then I am finding the row sum, row average. So, I am getting 0.59, 0.34, 0.06. What it implies? If the comfort is only criteria, the best car option is car A. Similarly, miles per gallon, if the miles per gallon is only criteria, the best alternative is car C. If the style is only criteria, the best alternative is car B. So, I got priority of all the alternatives for each criteria. So, that value I have brought it. So, with respect to price, this is the criteria which I got it. With respect to miles per gallon, I got this criteria. Already here I know what is the criteria weight, already we know the weightage for our criteria. So, 0.4, 0.09. So, when you do the matrix multiplication, see that I used MULT. So, I am getting this 0.27. So, my final conclusion is that the car B, that we are getting 41 percentage, that is the best alternative for selecting the car. So, for this set of criteria, for this set of pairwise comparison matrix, so we are suggesting the car B is the best option for that respondent. Dear students, in this lecture I have discussed about different project selection methodology. First, the technique which I have discussed is net present value, then calculation of this net present value using Excel, then I have used weighted scoring model for selecting the project, then we have discussed about internal rate of return, then I have discussed about calculation of internal rate of return using Excel. Finally, I have used a multi-criteria decision making technique called AHP. Then also I have explained calculation of AHP priority values using Excel. Thank you.